Okay, guys. So first, the reason we have limits is so that we can use them to prove continuity. I think you guys have a very good understanding of just the idea of continuity. Like on this graph, does it make sense that this is not a continuous graph because there's that little open hole in the middle of the graph? And same with this one, okay? Describing it in a mathematical way is very hard to do if you don't have limits. So the first one you might say, if this is the point, let's say that's at an x value of a, you could tell me the function value at a is undefined. Right, so that's a pretty easy way to say, okay, we know it's discontinuous because there is no value for the graph here. But if you look at this second one, if I call that a again, f of a definitely exists, right? Like there is absolutely a point there. It's just not a part of the line that we graphed. So this is why we need limits. We're going to use limits to determine, to prove that this is not a continuous function. Okay? Limits are not hard. We show them. All right, so first, this is how you write it. I'm going to write it all and then I'll tell you how to say it. I need an f of x in here. So this is the limit of f of x as x approaches a equals L. Limit f of x equals L, that's all like on one line. X approaches a is like a subscript of the limit part. Okay, it's right below it. The thing you need to remember with limits, it's all about what you are approaching. It's not about what the value is exactly at that point. It's what are you approaching. So I think of it as, pretend you're a little person here walking on this graph, okay? You're walking up to that point. Or you're coming from this side and you're sliding down the mountain to that little point. Could you find the y values both of those little people are approaching? That's what a limit is. It's just what is the y value as you approach it from both sides of your graph. Okay? So let's do some examples here. So the first one, this would be from your calculator. If you look at it, I asked you the limit of f of x as x approaches 3. You really don't need both y lists, you only need one. So when x is 3, we don't have a value. But look as you get closer to it from one direction and closer to it from the other direction. What y value do you see it squeezing in on? 6. That is the limit. Okay, so from a table, that's all you do. You look at the values on either side. What is it getting really close to? Your graph never actually touches 6, but it gets really, really, really close to it. Okay? All right, so let's do a couple that you could actually graph. Let's give you the equation y equals x plus 3. So first, what does the graph of y equals x plus 3 look like? It's a line. What's your y-intercept? 3. And then just up 1 over 1, right? Okay, that's what it looks like, correct? So the limit of y sub 1 as x approaches 3, or the limit of x plus 3 as x approaches 3. So think about your little person up here. They're walking towards that. walking towards that, what y value are they getting close to? 6. Yes. Does 6 exist in this graph? Yeah, and that's okay. You can still have a limit when the point is a part of the graph, or when it's not a part of the graph. So the limit equals 6. Okay. You with me so far? Let's say your equation is now x minus 3 times x plus 3 over x minus 3. So what happens here? There's a hole, right? And the hole is when x equals what? 3. So is my graph going to look very similar to the first one?
Yeah.
Yeah, but what's going to happen when x is 3? There's a hole. 3, 6, 12. So you've got this line, and there just happens to be a hole there. So the limit of your second y equation here, or of x minus 3 times x plus 3 over x minus 3, what is the limit going to equal in this one? Don't overthink it, guys. It is also 6. Okay? You are looking. So again, you've got your little person. You're walking on this graph. You're walking towards an x value of 3. What y value are you getting close to? 6. You don't go all the way to 3 because then you're going to fall through that little hole, and that's a sad day for your little stick person. Okay? You're going to approach the hole. You're going to go right up to the edge of the hole and look into it. And just think about what y value you're at. Okay? No falling into the hole. All right?
I don't think I'm going to be able to jump over.
Are you jumping in the hole? Oh, maybe. I don't know. All right, guys. So let's look. Yes, Sean.
So on a real scale, like each section passes like 1/3, how big would that be?
It only exists at that exact point, so it doesn't actually converge. Which I know it's the whole back to geometry and how the points don't have sides. Do you remember that? Geometry, big time. Sorry. Okay. All right, so this I think is on the right side of your page. Yes. All right, so what you are going to do is use this picture that I've given you, the graph that you have over there. It's kind of a funky looking graph. I want you to try A, B, C, and D. See if you can evaluate the limit as x approaches these x values. And you're just taking it all from the graph. What does it look like your little person would be approaching at those x values? Okay, so try A, B, C, and D. Good job, guys. Keep talking to each other. See if you can sort it out. Is C 0?
Oh, God.
No. C is tricky. I
Oh,
know.
no,
That's
go in the direction.
going to lead us nicely into the next part. That's why it's on there. So we'll talk about that.
No, C is 0.
We'll talk about that.
Maybe it's 4.
It's 4. Jack's just going to average them.
What I was thinking before I.
All right, guys, let's look. Okay, letter A, what did you get?
4.
4. Are we all in agreement about it?
Yeah.
Okay.
Negative 5.
Letter B, what did you get? Everybody okay with that? All right, I'm skipping C. Let's go to D. What did you get there? 0. Okay. C. All right, let's try C. So if I put my little person over here and they walk, they're getting close to 0, right? But their friend over here needs to also be approaching the same value. Are they approaching 0? No.
But if he falls off the
So
cliff,
it's
Right.
nothing.
If he falls off the cliff, then he's there, yeah. So it does not exist. So this is what we're going to get into next. We will talk about the left-hand limit and the right-hand limit. For the overall limit to exist, the left and the right must run into each other. Okay, they must be approaching the same value from both sides. So letter C is does not exist. D and E. Okay. Does that make sense now?
Good job.
I know you didn't know they had to match, but now you know.
Now you're very good.
All right, so the next little section here. I know it's really small on your paper. Do you guys see this tiny little negative up here
Yeah.
by the A? Can you see it? Okay. And do you see the little plus? Okay. So the first one, when we have the negative, that is called the left-hand limit. What that means is we only are going to evaluate the limit as we approach from the left. So you only have one little guy walking, and he only walks from the left. Okay? If there's a plus, what do you think that's going to be?
Right hand limit.
Right hand limit. So if I'm asking you to evaluate that, you're only going to look at it from the right. So let's get back up to this graph. If I had asked you the limit of f of x as x approaches 0 from the left, what would you have told me? 0. If I had asked you the limit of f of x as x approaches 0 from the right, I think 8 is where it's going. Okay? So you can evaluate the left-hand limit and the right-hand limit, but the overall limit over here is still does not exist. Okay. Okay, so now we're talking about the limit as x approaches 0 of the absolute value of x over x. Okay? That's what these graphs are giving you here. So really you're going to get a 1 or a negative 1. So the first part, as x approaches 0 from the left, the way you write that, limit of f of x as x approaches 0 from the left, you would say negative 1. Okay? Then the limit of f of x as x approaches 0 from the right, you would tell me positive 1. What if I asked you just the limit as x approaches 0 for this?
Does not
Does
exist.
Does
exist.
not.
They do not run into each other. Okay? So I don't like that there's an and in the middle of this box. We're just going to get rid of that. So if the limit of f of x as x approaches a from the right equals the limit of f of x as x approaches a from the left, then the limit of f of x as x approaches a exists. Okay? Once you have that, go ahead and flip the page. What? I think you flipped the wrong way. I think the stapling is throwing you off. All right, so try number 2 here. A, B, C, D, E, and F. Pay attention to those tiny, tiny, tiny little pluses and minuses. Like there's a minus right there.
Yeah, that's gonna destroy me on the
That's a
test.
plus. I will not make it such small font when I assess you, okay? I promise.
I have to keep going up. That's the plus or the minus. So 5 students have to.
I know. D is 5 from the left.
Limits are about the journey.
Yes, limits are about the journey.
Don't show.
Check with someone around you, see if you agree.
Yeah, you probably. No, I can't do that.
Counting, yeah.
At least you can read it. It's like someone asks you if you can lend them notes and they think you're just writing it on a curve. Like, I don't think you're not getting on top of that out. You gotta write DNA. That's actually great strategy.
Alright guys, letter A, what did you get? 3. Letter B, 1. Alright, did your left hand and right hand run into each other?
Wait.
So, C should be does not exist. Okay, that makes sense now, right? Yes, we're okay with that? Alright, letter D, what'd you get? 2. Letter E. 2. Letter F. Okay. We're doing okay? Once you see it, it's really not that bad. Okay, you're just looking at the graph, you're visually figuring it out. Okay, we are going to now use this as we determine continuity. So you guys have talked about continuity before, like you know about a hole in an asymptote and jumps, like you've heard those terms before, yes? Okay. You know how to just look at a graph and determine that it's not continuous, but now you're going to have to go through the formal way of stating it. So it's the continuity test. It has 3 bullet points. It's not as bad as IBT with its 5. Okay. 3 steps you got to show me every time unless it's not continuous. So first is that the function is defined at C. That means that f of C actually exists. Okay, so there is a point somewhere at the C value we're talking about. Then the second step is that the limit as x approaches C exists. Okay? So you have these 2 things existing. If they both exist, the third step is that they actually equal each other. So if the limit exists as you approach C, f of C exists, and they're equal, then your graph is continuous. Okay? And I'll show you, we'll do a couple examples here with how to do that. All right, so number 3, it says determine whether f of x equals 1 over 2x plus 1 is continuous at x equals 1/2. I'm going to use the continuity test to show you. So my first bullet point, we are checking f of 1/2. What does f of 1/2 equal? It equals 1/2, right? So, did it exist? Yeah, it's the thing, right? You found the value. Looking at that equation, where would this not exist? Negative 1/2, okay? So if I was asking you to find this at negative 1/2, just looking at the graph, you'd know, oh, that's not going to exist. You'd still have to prove it with the continuity test, but you should know yes or no it's continuous going into it. All right, so f of a half equals 1/2. That means f of 1/2 exists. Okay, so that's bullet 1. Then the second one here. The limit of the function as x approaches 1/2. Okay. You don't have to draw the graph of this. You can just think about what the graph would look like. You guys recognize that this is like a rational where you've got the asymptote at -1/2, curve going on here and here. Yes, you kind of can see it in your head. You just told me that if I plug in 1/2, I get 1/2. So what do you think your graph is, the y value is approaching as you go towards 1/2? 1/2. Okay, it's very redundant at this point, but yes, the limit equals 1/2. There's too many halves in this one, yeah. All right. So that exists. So then step 3 is saying that f of 1/2 equals the limit of f of x as x approaches 1/2. So yes. Continuous. F of x is continuous, sorry. So if either your first or second bullet is a no, like if f of 1/2 didn't exist, you don't have to keep going because you know at that point it's not going to be a continuous
Is
function.
this maybe like the IBT one where it's like a set and you have to write each bullet point?
Pretty much, yes. You're going to show what the f of whatever value is, the limit, they equal each other is continuous.
Are you gonna make it to an 8 instead of
No, that doesn't really sound like very much fun for me to grade, so sound cost. Well, you have to remember the first part of the IVT is that f is a continuous function. So I could, probably not going to make it.
Hey, yeah, I agree with you.
All right, so number 4, let's see if this is continuous. Is g of x continuous at x equals 0? Okay. So, step 1, we would need to find g of 0. Can we do that? Looking at me like,
You can plug it
Yeah.
in.
which equation includes 0?
No.
Neither of them. So does g of 0 exist? G of 0 does not exist. Therefore, g of x is not continuous. Yeah, you don't have to do the rest if it's not going
Yeah.
to work.
Is it kind of like,
have to do the rest.
is it kind of like,
I don't think this is like a proof.
no, I don't think so. It's the sky. A lot of coolers.
All right,
Raining Korean.
so what do you think about number 5? If I ask, is h of x continuous at x equals 2? What? It doesn't ever include 2, so your very first step would be h of 2 does not exist. Therefore, h of x is not continuous, and really we should say is not continuous at x equals 2. So sorry, I didn't
But it's not continuous.
It is.
Or I mean, like,
So let's say, okay, let's use this same equation and say, is h of x continuous at x equals 0?
but that's like specify the line in general is
That piecewise is not continuous at x equals 2. It is continuous in other places. So when we talk about continuity, I'm asking you at a specific x value, is it continuous? Okay. So let's do it for x equals 0. What would h of 0 be? -1. Okay? Because we'd use that first equation. There's our first step. Now the limit of h of x as x approaches 0. Am I doing anything with this piece of my piecewise? Does it matter at all?
I don't think so.
No, because I'm asking you about when x approaches 0. This has nothing to do with x approaching 0. This is all we care about up there. So that's a line, right? If you want to graph it, you can. Or what is the limit going to be as x approaches 0? -1, right? Yeah, okay. All right, are those two things the same? Yes, so h of 0 equals limit of h of x as x approaches 0, therefore h of x is continuous at x equals 0. Does it seem too simple? Like too easy when the, okay. There's going to be some where you don't have the equation, you have the graph, and you're showing me continuity, but the continuity test is really not that hard. Okay?
The first step
You can, if you just do this much, I would give you credit. Okay? All right. Ready to turn the page? Or go to the right side of your...
Luna equals.
Nope. That's not part of Calc A.
It's not part of A.
Not part of Calc A.
Oh,
Nope.
so it's next to it.
All right. So we have 3 different types of discontinuity. This is what I was saying. You've heard these before. An infinite discontinuity. That is an asymptote. I think you know that that's where the denominator equals 0. Graphically, you might have yes, I've seen this before. All right, removable discontinuity, that's a whole. That happens when a factor in the numerator and denominator cancels. Graphically, you can see a whole. All right, and then a jump only comes from piecewise functions. And it's when the left limit is not equal to the right limit. What? So it might be something like that. Move it up a little for you guys. An important part of this, you will not have 2 types of discontinuity at the same x value. Okay? So this is a jump. This is not a jump in the hole. Okay? I know this is an opening on the endpoint here, but a hole would also continue after it. Okay? So you're never going to have more than one type of discontinuity at a specific point. In a graph, you can have more than one, but they won't be at the same x value. Okay? All right. Let's just talk about 6 because I don't think you need another one of these. Is it continuous at x equals 1? What would you tell me? No. Why? Yeah, so f of 1 does not exist, right? What kind of discontinuity do you think this one is? Asymptote. The whole would be like there was an x minus 1 in each. That's okay. All right, so are we okay?
It's using algebra though.
It's using algebra?
Yeah.
Okay. All right, we are not doing 7 and 8. Just skip for now. Okay, we also have infinite limits to talk about. Yeah, it's a gigantic fact.
That's my breathe, my sleep.
All right, so when we're talking about limits with infinity, you know you have graphs like this where you've got the asymptote and then it continues up forever. So if I asked you the limit from the right, do you guys see how that would be approaching infinity? Is infinity a defined value? Like, is it an actual number? No, it's not 100. So technically, the limit still does not exist, but you can tell me the direction it's going because it does not exist in a very special way. So I'll show you what I mean. So the left-hand limit here, if we jump down to the graph has been given to you. So as we approach it from the left, is it going to approach an actual number? No. Where is it going? Down forever. What is down forever? Negative infinity. So the left-hand limit, you would have to tell me two things. Negative infinity, but hey, I know that that really doesn't exist. So I'm telling you the direction it's going, but I know that's not really a limit. No, they're not. Okay. So what about the right-hand limit? What are you going to tell me for that? Infinity does not exist. Okay. All right. Now, just the limit as x approaches 3. Did the left and the right run into each other? No. So what are you going to tell me? Just does not exist. Yes. Today's a good day. All right, so let's look at the next one. So now we have the graph of 1 over x squared, and we're doing the limit as x approaches 0. So from the left, what are you going to tell me? Infinity does not exist. Good. What about... Okay. All right, now this one's a little trickier for just the limit as x approaches 0. Are they both going the same way? So what do you think you want to tell me? Infinity, but still does not exist. Good. Oh, I know. What? Okay. All right. Let's keep going. All right, the next one. Okay, so this looks lovely, doesn't it? The limit as x approaches 0 of x minus cosine of x over 1,000. Okay, you don't have to graph that by me. This is the graph you're given. All right, guys, look up here. If you just look at the graph, doesn't it look like it's approaching 0? But look at your table. What is it actually approaching? Negative 0.001 is actually the limit. Okay, so if it's a calculator part, use your table. All right. Now the next one. you look at the table, it's negative 0.8269, it's error, it's positive 0.8268, then it's negative, then it's all over the place, right? Is it approaching a singular value? Or is it jumping back and forth? It is jumping back and forth. So, this is called a graph that oscillates. When it oscillates wildly, then then the limit does not exist. Oscillating, O-S-C-I, I think there's two L's, oscillating. Wildly. Okay. So, that is the time when your limit is not going to exist, because it's not settling in on a specific value. It is back and forth and back and forth. So there are 3 times when your limit is not going to exist. So the first is when the left hand and right hand limits are not equal. Second, the function doesn't approach a finite value. Just bring it here. And the third is the function oscillates wildly. Okay. Let's try these A through I. Don't worry about 5 yet. Try getting these from the graph here, okay? Letter B is kind of tricky. What do you think I'm trying to get at with -2 from the left? What am I trying to show in that graph? It's oscillating wildly, she told us, okay? So. Is it oscillating calmly?
Yeah, it's just the normal oscillation. No, not.
Yes.
So the limit of the function does not exist in those 3 things. Does that mean that it's not continuous, those 3 things? Or is
Because if the limit doesn't exist, the function's not continuous.
Oh.
So remember, the limit has to equal the function value at that specific point. So
Oh, yeah.
if the limit doesn't exist, then it can't actually equal the function value.
Next time on you open my house, you can get nails next time. Go and check it. I think the reason we're not getting like 0
All right, guys, let's go through it. Are you done? Okay, letter A, what'd you get? 0. Letter B. D-N-E. Letter C. All right, letter C. 3. Letter E. 0. Letter F. Excellent. Letter G. 1. Letter H. 1.
Green, no.
Letter I. 1. All right. Let's look at the last one on this page. Go ahead and graph this on your calculator.
Hey guys, don't forget, it's trigonometry, start your back. Hey, get rid of parametric.
All D and E.
Guys,
Guys, could you view this without a calculator? I said no calculator. So if we're talking 3 from the left, you can't plug in 3. Could you in your head plug in things on that side of 3? Yeah, you could have an idea of what the stress is doing without your calculator, but I'll let you use your calculator on it right now.
I didn't realize.
Well, yeah, why do it?
Well, if I can't do it on that calculator, I can't do it on this calculator. I swear to God. There's like a button that was probably like half the size. It was like a map.
Yeah,
Really? I don't know. It might be.
I can still write it anyway.
Yeah, I'm gonna.
What do you think, guys? What's going on with this graph?
Yeah, I'm not doing this on a calculator anymore.
What do we get? What do you think for number 5? I heard one mumble of an answer. It is not negative infinity.
I'm not.
Yes.
There's no like at.
Look at the graph, guys. What do you think?
1?
I am hearing 1. Yes, you are correct. Okay, 3 from the left. It is approaching 1.
Yeah, as long as you can figure out how to do it.
Because 2 on the left is 4. How could 3 be approaching?
Look at your graph.
I would appreciate it if I could see how.
You see it? Did you do after Make sure, guys, you're either using the fraction key or you are putting parentheses around your numerator. Okay? Otherwise, your calculator will not give you accurate information. All right, last one here. Last page, that is. Okay, guys, let's get through this. All right, limit as x approaches 2. Okay. If the limit is going to exist, that means the left hand and the right hand limit have to be the same thing, right? They have to run into each other. I don't think you really want to draw this. Do you want to graph it? You could, but then on a test when you run out of time, that's probably not the approach you want. So we are going to find the limit of f of x as x approaches 2 from the right, and we are going to find the limit of f of x as x approaches 2 from the left. Which piece is talking about x approaching 2 from the right? Okay, if we're coming from the right, is that numbers bigger than 2 or smaller than 2? Bigger than 2, right? So this is the one talking about from the right. I know the 2 is not included here, but could we plug it in to figure out what it's getting really close to? Okay, what do I get? 7. Okay. Then, as x approaches 2 from the left, which piece am I using? The top one, right? If it's from the left, that's number smaller than 2. Okay, so what does it equal there? 7. Are they the same? So, you can tell me the limit of f of x as x approaches 2 equals 7. Do I care at all for evaluating the limit that actually at 2 it equals 8.
No.
No, that's the, like, continuity test, yes, I would care, because then the function value and the limit are not the same thing. But just evaluating the limit, it doesn't matter, okay? Does that make sense? Okay? Alright. Well, I'm only asking you limit, I'm not asking you about continuity. So, you gotta know what I'm asking you. Okay. Alright, we have some sometimes, always, and never questions.
What do you mean?
Determine if it is sometimes, always, or never true. So, letter A, if the limit of f of x as x approaches 2 does not exist, then the limit as x approaches 2 from the right does not exist.
Sometimes.
Sometimes.
Not always.
That's not sometimes.
The left and the right could both exist, but if they don't equal each other, then the overall limit. Okay. Alright, now letter B, if the limit from the right does not exist, then just the limit does not exist. Always. Okay.
I know we have to get this all in, but
That's what? Yeah,
Alright guys, number 8. Without a calculator. I want you to find the limit as x approaches 3 from the right and as x approaches 3 from the left.
well, it's not like I can use my calculator. Pretty sure there's-
Make a little sketch of the graph from your brain, okay? Think about what would be happening at x equals 3. What does the graph look like? You know what it looks like, I promise. This is in your brain.
Ooh, I'm in your dome.
What is happening at x equals 3, guys? So, you also have a horizontal asymptote at 0.
Oh, shoot.
What does the graph do? It's one of these guys, right?
That's exactly, it's an L.
Alright, so the limit as x approaches 3 from the right, what would you tell me? Infinity does not exist. What about from the left? Negative infinity does not exist. Perfect. Yeah, so if I didn't ask you, but if I asked you just as x approaches 3, you would just say does not exist, right? Okay. Alright, one more little section where you're going to do it from the graph. See if you can finish up here before lunch. I realize that's not much time. Alright guys, let's start going until the bell rings here. Letter A, what'd you get?
1.
1. Okay, now they go down Alright, after lunch, the exciting conclusion. Alright guys, let's finish this. Okay, remember they go vertically here, so what would you tell me for B? Okay, infinity.
I want to ask a question about What's
up, Joel?
I just wanted to know if you did
Yeah. Alright, letter C, what'd you get?
infinity and
You need both, right? Not just the any?
Oh, I got that too.
Okay. Alright, letter D.
Infinity and does not exist.
Okay.
I thought that was a positive and negative.
I'm gonna go to I. I realize that is not the next letter, but just tell me I since it's right there. 0. Okay, then back up to E. F. G. H.
That is sore from carrying the entire class.
Zero from the right? Technically, yeah, you guys can't see it, but there is like an
That's
arrow.
actually pretty much what it is.
Okay.
Oh, I just focused it.
Yeah. No, there is. There you go. Alright, guys. I could. Your homework.
I'm gonna forget.
I prefer.
Just be prepared for me to forget the first thing.
Okay, guys. Questions on anything, and don't just talk. And don't take a trick quiz. We're taking the trick quiz first.
What is the definition?
Not yet. So write 20 of them. Please practice on yourself.
40 practice problems.
Yeah, can we have a 40 question trivia?
No.
A little bit of time. Can you increase the amount of questions?
Just tell me. An hour and a half.
I want 100 questions for 1 minute.